Hello, welcome. Today let's try to solve another Leetcode problem 444, sequence reconstruction. So we are given an array of sequences. So inside of the sequence is just a subarray. So for example, for this one, inside of the sequences, there's a subarray, this one too. Yeah, it means if you want to take cos2, you must finish cos1 first. So let's see the representations. Yeah, we are just giving an integer number array. Yeah, we want to check if there's only one unique numbers. So these unique numbers, yeah, let me say, let me check how can I explain it. So these unique numbers, just yeah, for example, this is a subset, it is 1, 2. Another subset is 1, 3. Yeah, so it means we have two combinations. One is 1, 2, 3. Another is 1, 3, 2. Because inside 1, 2, 3, we can find 1, 2 and 1, 3. Inside 1, 3, 2, we can also find those two subsequences, 1, 3 and 1, 2. But we want to find only one numbers, only one. At the moment there are two, that is why it is false. We need to find only one. So this is a typical topological sort problem. Basically, we want to find a unique combinations. So let me make a drawing of what does it mean. Yeah, so it means, so for example, this is a 1. We want 1 to connect 2 and connect 3. We just want to have this unique topological structure. So for example, there is another 3 maybe also connected to, there's another number 4 maybe also connected to this number 2. So it means that there are two different sequences. It can be 4, 2, 3, or it can be 1, 2, 3. Yeah, but we want to find only one unique, only 1, 2, and 3. Yeah. So this means for the topological sort, let's try to use another example. Maybe we can use this example. Yeah, 1, 2, 3. We have 1, 2, 1, 3, and 2, 3. Let's use this example. So we have 1, 2, 1, 3, and 2, 3. Yeah. So if we have this kind of a structure, so we want to find an array which have those three subarrays. So there's only one result. It is 1, 2, 3. Because this 1, 2, 3, it include 1, 2, it include 2, 3. It also include 1, 3. It also include 1, 2, 3. But there's only one unique result. So this is why the topological sort works. Yeah, we're gonna start the topological sort BFS from the node 1 because there's the integrity for node 1 is 0. Now we're gonna go to this node 2 and node 3. Because for node 3, the integrity is 2. While we take out this one, the integrity is 1. But while we take this integrity for the node 2, it is 0. So for the next one, it will go to 2. And then for the next one, it will go to 3. But for each of the step, it can only go to one node. It cannot go to two node or more than two node. Yeah. So this means this is the unique result. If it can go to two node, for example, from 1 to 2 or from 1 to 3 at the same time, it means the result is not unique. So that is why the topological sort works. But we need to do some tricks to solve this unique problem. Let me prepare two variables, the graph and integrity. So the graph would be a default dict. Inside it would be a list. And the integrity would also be a default dict because I'm not sure how many nodes, it is always dependent on the sequences. So inside, I'm gonna put an integer. Now I'm going to prepare a unique set. This gonna check how many nodes inside the sequences. So the unique would be equal to set. Inside it will be n for s in sequences and for n in s. So this basically check how many unique nodes, like 1 and 2, and it can be others. Yeah. Now I'm going to prepare the integrate. So for n in unique, the integrate n for this node would be set to 0 from the beginning. Now I'm going to start the graph preparation and integrate preparation. So for here, I'm going to prepare this graph. So for array inside the sequences, and for let's prepare another two node UV in pairwise A. So for example, this sequence it is 1, 2. The pairwise will be 1 and 2. So if it is longer, maybe 1, 2, 3, and 4, I will always prepare the pairwise because it has a sequence. It will first finish 1 and then 2 and then 3 if there's another 3 after it. Now I'm going to prepare the graph. So for the graph, it would be gu.append this way because it will start from u and then to v. And for the integrate, it will be the v, so the plus equal to 1. Now I'm going to prepare a queue. Actually, it is like a stack, but I'm gonna define a queue. So queue I for id in integrate dot items. So if d equal to 0, now I'm going to check this queue. I also need to prepare another variable result. I need to check the sequence of the node. So the result would be an empty array. Now I'm going to check this queue. So if the length of the queue is more than 1, so this means inside there are 2 nodes at the same time. You can choose either, maybe there are 2 nodes 1 and 2. You can choose either 1 or 2. So this means it's gonna be a false. It means there are at least 2 different cases, but we need to return only 1 unique cases, that is 1, 2, and 3. So we can return a false immediately. Otherwise, we are sure the queue, there's only 1 node inside the queue. It should be equal to queue.pop. And we're gonna check the neighbors. The neighbors should be inside the G node. Now we can prepare the integrate neighbor, should be -1, and we're gonna check this integrate neighbor. If it is 0, we just put it inside the queue. Actually, this is the entire code. If we didn't return a false, we're gonna have a result. So this result should be equal to the nums. If it is equal to the nums, it means it is unique. If it is not, it's gonna still be return false. For example, this one. The sequence is 1, 2, and for our result, it should be 1, 2, but the nums is 1, 2, 3, it means it's gonna be a false. If the nums is just 1, 2, it's gonna be a true. Now let me run it. There's some mistakes. Number 3 and 4, let me just have a check. It's gonna be false, false. It seems I always return false. I didn't even return a true. Let me check what is wrong. So this is my in degree, and this is a pairwise A and GU. The first one should append this way, and the in degree of this V should plus 1, and this is the Q. Yeah, this is strange. I just solved it. I think it should have no mistakes because while I'm solving it, there's no mistakes. But now I have a mistake. I have to check why. Let me first check from here to check if the Q is right. So for this example 3, let me check what's inside of the Q. It should have a 1 inside of the Q. It means it is right. Yeah, because for this one, it's gonna be 1, 2, and 3. Now let me check this nums. Check the result. Yeah, let me just check what is the result inside. Yeah, it is empty. Yeah, it is empty. Why? Because I didn't put it inside. Yeah, I needed to put it inside. So here, while I pop out the node, result should append the node. I think this is why. Now let me just run it. Yeah, as you can see, it works. Now let me just delete the grid and submit to check if it can pass all the testing cases. Yeah, as you can see, it passed all the testing cases and it's pretty fast. Now let's analyze the time complexity. So let's check the value of n is 10 to the power of 4 and this n is the nums.less. So let's check from here. So for this unique, basically it is it is the sequences. And inside of the sequences, it's gonna times how many nodes. Let's check the length of the sequences. It is 10 to the power of 4. And for each of the lengths, it is 10 to the power of 4. Yeah, so this one actually, it is n squared already. Yeah, but it can pass. Yeah, because while we are I'm using this unique, and for this set, and for this array, basically I'm check all the sequences, and the length of the sequence is 10 to the power of 4, and for each of the sequence, it is still 10 to the power of 4. It means this is already n squared from here. Yeah, and I cannot avoid that. And for this one, actually, for this unique, it's just inside of the set. It should be smaller than that. It will be 10 to the power of 4. It will be on. But here, it is on squared. Now let's check from here. So for inside of the sequences and pairwise, it's gonna still be on squared. Now let's check the last BFS. So from here, while we are checking this Q, if it is only 1, we're gonna still check the next if it has more than 2. So we're gonna not analyze the false because false will be smaller. We're gonna always check this is true. So for this is true, it's gonna be on. Yeah. So the final time complexity it is on squared, and the on squared is coming from this unique actually from here. Yeah, because this while loop is just on. Yeah, let me check. It is not on. It is on square. Here is also on square because for neighbors, basically we're gonna check how many edges, and the edges will be maximum n square. Yeah. Yeah, because this for this BFS actually it's gonna check each of the vertices and all the edges. It is O E plus V, and this E can be V square. It means n square. So the time complexity is O n square. Thank you for watching. See you next time.